Okay, so today we're going to talk a little bit about the heart. Previously, we talked about cardiomyocyte cells and the algorithmic cells, and today we're going to talk about how they work within our heart and how they work to depolarize and repolarize our heart so that we can get blood pumping and moving through it. So I guess the first part is that we should draw a heart. Okay. Okay, here we have the centerpiece. Like kind of like this, and then this part is longer out here. Yeah, something similar to this. So within our heart, we have negative. This part, the top part of our heart tends to be more negative, while the bottom right part of our heart tends to be more positive. And so when we measure how much someone's heart is pumping, we do it through something known as EKG. And in order to measure EKG, we measure it through the electrical signals that we are fed back through different waves according to whether they're moving from an electrical gradient to a positive gradient or from the electrical gradient back towards itself. And this gives us positive and negative feedbacks. And they kind of end up looking kind of like these little waves, stuff like that. And so as we see how the electrical gradient moves, we'll start building our wave. So first, we normally start off here on the top left of our zone when we of our heart when we start in a place known as the SA node. So what do we know about an SA node? Well, we know that an SA node is an algorithmic cell, so it doesn't use any sodium. So it is triggered by CAMP that opens up the funny cell channels, or the HCN and the I-acetylcholine channels respectively. And this causes it to start depolarizing the cell in this way, on this part of the cell. So it kind of moves this way down from the electrical gradient, the negative gradient, towards the positive side. And so this triggers a positive feedback, because whenever we go from a negative towards a positive, or positive towards a negative, that gives us a positive feedback into our little wave thing, or it makes the wave go up, is what I'm saying. Well, if we do the same, so we go from negative towards negative, or positive towards positive, that causes our wave to go down.
It makes it upside down.
Yep, it goes the opposite way. So, as we see here, we're going towards the positive side, so our wave is actually going to go up, and it's going to continue depolarizing until it has all of this done, and then it's going to depolarize towards the center. And this gives us our first wave, known as the P wave. And so this P wave here is the first act of depolarization.
Depolarization of which part of heart?
The upper, the left, and the upper right part of our heart.
So what do we call about those two parts?
The atrium.
Yes, depolarization of atrium. Yes,
Yeah, so the atrium.
It makes a P wave.
Yeah, it gives us a P wave. And this goes in to the AV node. So now that we have that depolarized, or in a negative field, because this is now negative, we actually are going to start depolarizing the cells. But first, we depolarize this part right here. And since we're turning backwards a little bit from the negative towards the negative side, kind of going like this.
No, it's the left side.
Yeah. Yeah, like,
left superior septum. So it should go this, no, that's the right side, this way.
way?
Yeah, left ventricle
Okay.
is there.
Here's one of these two sides.
So superior left ventricle, so
Over
it
here.
goes this way.
Okay, it goes up.
Mm-hmm.
And since we talked about it, even though this is the negative side, and this was originally positive, it is now negative because it has been depolarized.
Yes, so we call this negative tail towards the negative.
Yeah,
Yeah.
and this causes, as we talked about, a negative towards negative feedback, which makes us go down into what's known as the Q wave.
Yes.
And after we're done depolarizing this part right here, we start.
No, we do not depolarize that part. Those are the empty spot. Those are the empty spot that we
Right here.
blood fill, so it should go this way.
It goes. Oh yeah, it goes straight down. We go straight down here, and we start depolarizing this part that's close to the wall.
Ventricular wall.
Yep. And once we finish these ventricular walls, because there's so much that we just covered right now in this moment, we actually have a huge spike up that later comes down. And so having this part depolarized, we're still going from negative to positive. And so that's why we had this huge spike. But now that we start going this way,
So what is the name of that way?
well, this isn't, oh yeah, sorry. This is a Q wave. And this huge spike here is known as the R wave.
Okay.
And this leads us into our S wave.
Yes.
Since we're going up here and finishing this part up, that has a little bit more, so we go a little bit up.
Why there's a little bit more? Why it takes longer than right side?
Because the left side of the heart is bigger.
Left side of the ventricular wall is thicker than right side. Yes, because we have to pump the blood to whole body system. So the muscle in that side is thicker than right side.
This is where our body pumps out blood.
Yes.
So we come down and then we go up.
So what makes the upside down wave?
The upside down wave is caused from going from this, even though we're already negative here, we're going towards the upper part, which is now more negative.
Negative tail towards the
upper left.
more negative part, right?
Yeah.
Yes. So it makes it upside down. Yes.
And so this makes it go upside down.
What is the name of the wave?
This is an S wave.
No, that's not. S wave is upside down.
Or the S wave is the upside down part, right?
Yes.
Yeah. And then once we start repolarizing, we do a T wave. And this T wave is caused from us going from here, from the apex of the heart here, back from the positive to a negative side.
Positive tail towards negative lead. Okay.
And so this makes us go backwards and has us start repolarizing the cell in a way that is now becoming positive again.
Okay, which wave move towards epi to endocardium?
Epi to endocardium.
Which one?
Different.
There's one wave moves the field move to epi to endo. Which wave move to epi to endo?
Not sure.
So epicardial means outside, outer to inside, right?
Out of the inside. So that would be the S wave.
S wave moving inside to outside. They depolarize the cell to in and out. So inside to outside, they're moving.
Yeah.
So
it would be the S wave here going this part, right? Because we're moving from this part here into the outside
this
of the
is
way.
the endo to epi.
Yes.
Yeah, there's a one is the epicardium to endocardium.
Okay. Anything else?
Which one will be, do you think?
It would be the S wave, would it
No.
not be? Because we're coming here to here.
It moved the endo to epi.
So we
Inside to outside.
inside to outside. Would that be the T wave then? That's going back.
Outside
From
to inside,
side?
right?
Yes. Okay, that makes sense. So we're coming from the outer ventricle into the inside of the cell, and we're starting to repolarize it.
Yes.
Okay.
Yes. Anything else?
I guess to kind of refresh on this, so the way this kind of works, it kind of looks like a little box here. And this little box, it would be like, this would be the membrane here. And as we can see here, when the cell is more polarized, or depolarized, the inside of the cell tends to look like this, negative, while the outside looks positive.
When the cell depolarizes?
Yeah, when the cell is depolarized.
Oh,
So this, the end, we're right here.
okay.
So it looks like this. And so,
Repolarizes.
so
You
we're-
mean when
we're-
the cell
yeah.
repolarizes.
yeah, at the end of depolarization, right before we start repolarizing.
When you depolarize, the inside the cell must be positive, so it
Yeah.
should be repolarizes.
When so this is how the cell originally looks. Positive inside and negative on the outside.
Okay, which wave is that case?
This right here is the start right here.
P wave, yes.
It's the start of P wave. And as we start moving towards those, we start changing from positive to negative. So we see like a change, kind of more like negative, negative, positive, positive, positive.
Okay.
Kind of like this. And then soonly enough, the negatives start taking over.
So which one tells the repolarization of the cell?
This would tell the repolarization of the cell.
Which one tells the depolarization of the cell?
It'd be this one right here.
Yes.
No, thank you.